Hello, grade 11s. Let's look at electrical circuits from our physical sciences, one of the previous question papers. So, we've got a question reflecting, guys, on the screen. It's basically question 11. That was the last question of that question paper. So, the circuit below is used to determine the resistance of X. We're going to use that to determine the resistance of X, which is this one. And now we then need to study the circuit. Look at your battery, which is going to be this one, guys. And from the battery there, you can tell that your positive terminal is actually on the left and your current is flowing, in clockwise directions, going like this way. Your current is going this way. Your current is going that side. All right. So from here now, we understand also that the ammeter is connected in the series, so it means now the ammeter measures the total current of the circuit. And then you have the 8 ohm resistor and also the X resistor, and your switch there, it seems to be opened. There's no current flowing in the circuit. The 12V battery has negligible internal resistance. When switch S is closed, wow, now they're closing the switch. It means we're going to explore the flow of current in the circuit. The reading on the ammeter, it's going to be 0.5. Just want to attach the 0.5 there. The reading on the ammeter, it's 0.5. Just want to reduce, guys, the size of my pen. All right, thank you so much. So we have got 0.5 as the ammeter, the reading on the ammeter. Okay, so the first question says state Ohm's law in words. State Ohm's law in words. It basically says the potential difference across a resistor is directly proportional to the current flowing in the conductor. The potential difference across a conductor is directly proportional to the current flowing in the conductor, provided temperature remains constant or at a constant temperature. Guys, take your examination guideline and then just look at it. It is the first bullet of your examination guideline. Please make sure that you're going to use that one. All right. So the next question says calculate the resistance of resistor X. Look at where resistor X is, and then from there you have the ammeter. You have got how many resistors there? You've got 2 resistors, and 2 of them are connected in series. So for you to be able to get the resistor X, you can use this formula. Remember, RT equals to R8 plus RX. So when you look at it, you have got the R8. You don't have the total resistance. You don't have the resistor X as well. So you need to find out the resistor, the total resistance of the circuit first, so that you can be able to calculate Rx. So let's find that one, the total resistance of the circuit. You're going to say RT equals to, we're going to take advantage of Ohm's law because we have the voltage of the battery and the current flowing in the series circuit. So you're going to have your V over your I, that is going to be your 12 over 0.5. 12 over 0.5, guys, on your calculator, it's going to be your 24. So you're going to have 24 of voltage there. 24 of your voltage is actually flowing there. All right, so from here, you have got the total resistance of the circuit. So you're just going to substitute now this into this formula to get that, because you have that. You're going to have 24 equals to 8 plus your Rx. So you make Rx the subject of the formula. 24 minus 8, I think, is 16 of ohms. So it means this one, it's going to be your 16 there. Going to be 16. So we're done with 11.1.1 and also 11.1.2. So let's go to 11.2, guys. It seems like it's going to be a lot of calculation for us to work on that one. Study the circuit below. The battery has an EMF of 12. We've got the EMF of 12 with negligible internal resistance. It means the function or the work function of that internal resistance is basically insignificant in this case. All right, so let's analyze the circuit. Switch S, guys, is closed. We close switch S, and then from there the current is flowing clockwise. So when the current gets to this point, another current coming this side, another current coming this side. It means now this one and this one is going to be your 20 because they are connected in series. So 20 ohms. And from there now we need to look at this one that is connected in parallel. I'm just going to get the effect of that. It's going to be R1 times R2 all over R1 plus your R2. So let's look at it. We're going to have your 16 times your 4 over 16 plus 4. 16 times 4 is going to be 64 over a 20. It's what? It's 4 times 16. It's 64 divided by 20. And then it's going to be 3.2. We're going to have 3.2 ohms. So now this 3.2, guys, and also the 20 are now connected in parallel. So if we want to get the effect, it's going to be, let me just say RP2 equals to, I'm just going to have 3.2 multiplied by your 20 over 3.2 times your plus your 20 there. This one, guys, is a plus sign. So plus your 20 there. Now, so we're going to have 3.2 times your 20 over 3.2 plus your 20. And then we're going to have 2.76 of ohms there. So it means this is going to be the total resistance of the circuit. Why am I saying that? Because remember, guys, for us to be able to get there, what we did with the circuit, we analyzed the circuit and understand that when the current gets to this point, the current is going to flow to that side and flow to that side. So now this is basically connected in series. We can add them. So it's going to be 20 ohms. Then we said this 20 and together with this one are connected in what? In parallel. So we then got this effect from this one as your 3.2 ohms, 3.20 ohms, because we said that Rp equals to R1 times R2 over R1 plus R2. Then we said 16 times 4 over 16 plus 4. Then we got that one. So we said that one now it's connected in parallel with the 20. And then we were able to arrive to 2.76. So write down the potential difference across the 4 ohm resistor. Which one is the 4 ohm resistor? It's going to be this one. So it's going to be a 12V. I'm going to explain why it's a 12V. So we need to understand that this battery supplies 12 of joules of energy, which is 12V, and into this parallel circuit, into that parallel circuit. So now if it supplies that into the whole parallel circuit, then it means now remember this branch is parallel to that branch, so there's a 12 coming here, and also now there's a 12 going to that very same 12 plus 8. So now the one of the 4 they're asking us about is this 12, and then if there's total of 12 going to this parallel connection, so it means there's 12 going to the 16 and there's 12 coming to the 4 because they are both connected in parallel. So that's why we're just going to write 12V here, guys. You need to understand the flow of your current. Calculate the reading on the ammeter. The ammeter is this one. Wow. And then we need to calculate the reading on the ammeter. We're going to use Ohm's law. So the ammeter reads the current that is basically coming from the parallel branch. So how are we going to account that? R equals to V over I. What is R of that total branch? Is going to be your 3.2 of the total branch. 3.2 equals to, so your V is going to be the 12 that we said. It's basically the total of the energy that is supplied in there, and then over the current. So 3.2 I equals to 12, and then we say 3 over 2, and then 3 over 2. So I equals to, we're going to have 12 divided by 3.2. We're going to have your 3.75 of your amperes of current there. We're going to have 3.75 of the amperes of current flowing in that one. All right. Such a simple question, guys, to answer. So calculate the energy dissipated in the 12 ohm resistor in 2 minutes. So we have got, the resistance of your 12 ohm there, and then the change in time, guys, is going to be 2 multiplied by 60, which is 120 seconds. And then the question is 5 marks. Let's look at, the 12 ohm resistor. Oh, the 12 ohm resistor is basically that one. Wow. So we have to calculate the energy that is dissipated there. What is it that we need in order to calculate the energy? It depends with the formula. We basically need all the dimensions of your Ohm's law. So remember this: W equals to I squared R, change in T. This W equals to V squared over R, change in time. And this W equals to your VI, change in time. So in this case, guys, I think we're going to use formula number 3 because we've got this one. We've got change in time and also the voltage, the total voltage that is flowing in this side. And then from there, we're going to have W equals to V squared over R, change in time. This one is going to be your 12 squared over 12 multiplied by 120. So let me see, we're going to have your 12 squared, and then we have got the 12, then multiplied by 120, and then we're going to have 144 of joules of energy there. All right, let me analyze and see if we did the right thing, especially in terms of the 12 there. So that is the total voltage that is going in there. Guys, the other thing is, if you want to prove if you're doing right or wrong, you can just look at the fact that, the 12, this side and this side are going to be shared. And then that is 12 plus 8 is going to be, total of, let me say, VT equals to the 20. So if you want to understand how much of the potential difference, oh yes, that actually came into the 12 ohm resistor there. That is going to be that one. So you're just going to say 12 over 20 of the total multiplied by the 12. So which is going to be 144 divided by 20 is going to be 7.2. 7.2 voltage came there. So in the place of this, guys, we are going to use the 7.2 square, and we're going to have 7.2 your square divided by your 12, and then we'll multiply by 120. Then we're going to have your 518.4 of that. So this is going to be the answer. Thank you, guys. Please make sure that you subscribe with us so that we can be able to interact a lot. Thank you, guys. Bye-bye.